Hi, in this video we're going to look at trying to find a formula for calculating the gradient of a curve. Now before we do that, let's go back and remind ourselves how do we calculate the gradient of a straight line, because in the previous video I showed you that if you had a curve and you drew the tangent and you could find the gradient of the tangent, then you got the gradient of the curve at that particular point. So here I have a straight line, and if you remember from your coordinate geometry, if this is P, this is the point Q, then to find the gradient all we need to do is find that distance there, which in this case is 4, and then divide it by this distance here, which is 3. And if you remember, if you label the coordinates x1, y1, just move that up there so we can just it goes with it. X1, y1, and this is P that has coordinates 1, 1, and this one is x2, y2, then you can find the gradient by doing y2 minus y1 divided by x1 minus x2 minus x1, and in this case our gradient will be 5 minus 1 over 4 minus 1, which is 4 over 3, which is 1.33. And we've got this distance here, which is 3, which is quite important when we come to the next bit. Okay, that's how we find the gradient of the straight line. Now let's have a look at a curve. Right, now we've got a curve. This is actually the curve y is the f of x is equal to x squared, okay? And say I want to find the gradient at this particular point, which is px f of x. So this would be the point 1, comma 1 squared. Now, if we draw the tangent at this particular point, which is this red line here, then the tangent is actually y is equal to 2x minus 1. And we can see from using y is equal to mx plus c that the gradient there is 2. So we know the gradient here is 2, but how would we actually calculate it? And this is what the beginning of calculus is all about. So what we do is this. What we do is we select a point not too far away from the point P. For the moment I'm going to put my second point at point 3. And if you remember, this is called a chord. Okay, so this is a chord, okay, and what we're going to say that this chord here, this line here, is an approximation of the gradient of the tangent. You can see there's quite a bit of error at the moment, but maybe we can improve our estimate. So if that is the gradient at this particular point will be this distance here divided by this distance here, and we call this distance here h. Okay, so this from here to here we would have to subtract the y coordinate, so it's going to be f of x plus h minus f of x, which we get here, okay, and this distance here, this one here, is going to be x plus h minus x, which just gives me h on the bottom. So this gives me the gradient. It's like using y2 minus y1 over x2 minus x1. What we say is this point is x plus a little bit, and then it's f plus x plus a little bit. So you need to really understand function notation as well. Now obviously we can see that this line here is not a good approximation to this line here. So what can we do to make it better? Well, we could move the point Q closer to the point P, and we do that by making h smaller. So what I'm going to do now is I'm going to make h at the point 2. So we've got the point x coordinate 2, which will make the distance here. So this is now at x is equal to 2. So this distance now is 3, and this distance now 1. So we now find the gradient is 3 divided by 1, which is 3. Still not a very good approximation, because this line is like a long way from this line here. So we could make it even better by moving h even smaller. So let's just make it half the distance again. It's a little bit fiddly. There we go. Okay, so we're looking down here. We can see this distance is now 1.25, and this distance here is 0.5. So this coordinate will be 1.5, comma 1.5 squared. Okay, So, which is so that gives me a gradient of 1.25 divided by 0.5, which gives me 2.5. It's still quite a way out, so we could make it even better by making it even smaller. Let's try and make it 0.1 if we can. Okay, you can fine tune it. I put this applet with the in the notes of this video. You can see it's very, very small there, but this distance here is now 0.21. This is now 0.1, so we get 0.21 over 0.1, and we get 2.1. What we notice is that my chord is starting to coincide with my tangent. I could do it even smaller, so if I do it even smaller, okay, so I just want, let me just move it with the arrow keys, it's easier. Okay, now we're at 0.01, so this distance is so very, very, very small you can't even see it anymore. And this distance here you can't even see with 0.0201. Now we could actually zoom if we wanted to, but we'd lose all the other information. So we get that the gradient here is 0.0201 divided by 0.1, which is 2.01. And nearly, you can see the red line is now coinciding with the chord, which is the blue dotted line, is now actually coinciding with the tangent. And we can do it even better, because we could move this down so that we've got 0.01, and now we've got that the vertical distance, although we can hardly see it, is 0.002 divided by 0.001, and that gives 2.001. And I can even do that even smaller, couldn't I? I could do 0.0001, and I'm going to get the answer of 2.0001, and that could carry on indefinitely, okay? And we could actually zoom in on here, but it's quite difficult to do, and find that we've got a little triangle here. Now we can't make h exactly 0, because if we did that, there'd be no gradient, because you can't. There's no distance this side. There's no horizontal distance to divide by. But if we make it that, and that's as small as I can do with this particular software at the moment. Okay, I can get the gradient as 2.001, and this is 2. But if I make that distance infinitely small, I will get the answer of 2. And we get to, just click there, there's a table there of what I've just done. Taking each point, the P point and the distance 2. And so the distance between the y coordinates is 9 minus 1, 8 divided by 2, which is 4. Here, this one's going to be 4 minus 1, which is 3, divided by h, which is 1, which gives me 3. Here I've got 2.25 minus 1, which is 1.25, divided by 0.5, which gives me 2.5, etc. And you can see this is converging. I can do it even smaller, and I see I'm going to get very, very, very close to 2, but never actually equal to 2. And so what we say is this. The gradient function, or the gradient, which we call dy by dx, and this process is called differentiation, is the limit as h goes to 0. So what we're doing is, if I just move this up so you can see it, we're making this distance here very, 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 very small, infinitely small. This is what this means, of f of x plus h minus f of x over h. And you saw when I did that, and that's as small as I make it, the gradient will actually approach the actual value it is, which is 2. Okay, and this is called differentiation by first principles. And in the next few videos, I will show you how to differentiate x squared by first principles, and then eventually we will come up with a formula for finding the gradient using algebra, and then being able to substitute a value of x in. And that process is actually called differentiation. Okay, this has been a video to show you how to the introduction of differentiation. Both the GeoGebra applets I've used in this I will put in the notes of the video. I hope you've understood, and I thank you very much for watching.